right? And if others of you are, are likewise talented, come on, get me up here. Let's do it. We always take the first few minutes just to entertain ourselves and get in charge. All right. So for Thursday is like March 1st, and that's the deadline for deciding whether or not you're going on the field trip or doing the term paper. And so we will pass around a list. You can choose what you're doing. Okay? Yes. Say that louder. Yes, the day of the field trip is on the syllabus. And the deadlines for turning the term paper on the syllabus, as are how long the term paper should be, and its objective. Yes?
Is there a limit to how many supposed to go?
No. Not in this class. No, you can't bring your girlfriend, boyfriend. Yes, but you can bring your mom or dad. Yes?
Do you know when the field trip is then?
Yes, but I don't know off the top of my head. It's the end of March.
March 30th. No, where?
Oh, no, I haven't completely planned out the field trip yet. Okay, good. So that's one thing that's coming up, and the other thing that's coming up is that all of you will do some kind of multimedia, very likely a PowerPoint, on some environmental issue, okay? So be exploring in your mind. Where is your passion about some environmental issue? And I've given you some examples there. For those of you who are doing term papers, it would be on the same topic, okay? All right? Some of you will do a PowerPoint. Some of you will do some other form. A Prezi is another form. Some of you may do movies, and that's really cool. And those, I will then call for volunteers. And I've saved the last like 5 or 6 lectures for a lot of you to actually give your presentations. And that material goes on the final exam, although the people who are volunteering are not graded on their presentation. That would be unfair to those who can't. Yes?
Are they groups? Are we doing it in groups or by ourselves?
No, you're by yourself. But if some of you want to get together, maybe I'll let you. But I really want to see individual efforts here because it's for your individual grade. Okay? Any other questions about number 1, the field trip, term paper option, decision on Thursday? Questions about the presentation? Okay. And then Emily, God, that was what a deal. I was so excited. So let's do clickers. Yeah. And we got 2 lectures to do. Sorry I missed you on Thursday. Hope it went okay. But I had a duty. I needed to go see my 92-year-old parents. So, they're in Texas. Trying to tell them that they should move to Boston. It's that time. Up here. Clean up my act. Okay, here we go. Multiple choice 6 questions on air pollution. CO2 in the atmosphere today is approximately 285 parts per million, 370 parts per million, 2.8 parts per million, and 2.8%. Now, none of those are exactly right because I should have upgraded this. But what's the best answer? Click away. Click. Wait, I haven't got turned on yet. And I'll do that right now. And now the polls are open. You're firing away. Countdown. What's the best answer? Woo, woo, woo. And count. Hurry up. You're almost done. 2 seconds. 1. Get your clicker out. And you said a whole lot of you're all over the map. Wow, that's why we do this. The correct answer is actually 390 parts per million, or 385. Last time I looked, a week ago. All right, so it's still, that's how fast it's going. I made this clicker slide 3 years ago, and it was 370. It's not there anymore. It's changing every year. Okay, but you chose the best answer you could, and that was 370. The correct answer should be more like 390 or 385. Okay. Nitrous oxide is an air pollutant, but how is it made? Nitrogen is the most abundant element in our atmosphere. Now we'll turn on the polls now. Forms from combustion or burning of oxygen in a nitrogen-rich atmosphere. From the effects of ultraviolet radiation on nitrogen and oxygen. From lightning from the burning of high nitrogen, high oxygen fuels, and 5 natural processes. I will now turn on the polls. Your polls are already open. I'm now doing the countdown. Go ahead and choose any answer. It looks really good for you. A lot of you don't know this one yet because that happened a week ago, right? This lecture was a week ago. And that's why we're doing it now. Getting ready for the next midterm. And there you are. You're scattered. The correct answer is number 1. All right? Our atmosphere is rich in nitrogen. Plants love nitrogen, but nobody likes nitrous oxide. It's an air pollutant and it's created by combustion. So is that a combustion air pollutant or photochemical? Is it combustion or photochemical? Look at the word. Combustion. There's only one photochemical air pollutant. Okay. We are imprinting. Cool, Dr. A. Which of the following air pollutants is photochemical? Nitrogen dioxide, ozone, sulfur dioxide, carbon monoxide, or lead. Okay, polls are open. There's the countdown. Real exam questions. A lot of these will repeat. All for you. A gift of love. There's the, hurry, 3, 2, 1, fire, fire. Got in. Polls are closed. A whole lot of you chose the correct answer. The check mark is a little bit off. The correct answer is ozone. You know, that check mark is perfect on my computer. There's something about the way it projects. Now, and the rest of you scattered a little bit. Okay, only one photochemical. Only one. Ozone. Ozone, it's a 2-stage process. The ultraviolet radiation, the 1% that does get in, blasts away at nitrous oxide. Knocks off one of the oxygens. And then that free oxygen cannot stand to be alone and grabs an O2, making an O3. It's unstable, but while it's there, it is O3. Very reactive ozone. Okay? It is also ozone. Is also made by lightning. It's also made by high energy cars, race cars. If you go to a racetrack, you can smell the ozone coming out of spark plugs. All right? So ozone, ground level air pollution, is photochemical, also made in 2 other ways. All right, there we go. It's the only photochemical in a 2-step process. An inversion layer, which traps air pollutants, occurs when cold air underlies warm, when warm air underlies cold. Wherever the ozone layer is diminished, during sunny days, and all of the above. What do you think? Now, I read it slowly. Only now do I open the polls. So if you fired earlier, fire again. Your last fire is the one that's registered. And the countdown goes. Excellent. Here we go. Emily now has 170 people as a fan club. Fantastic. Hey, get in here. All right, there's your seat. And this is excellent. You're all over the map. Because this was a week ago. The correct answer is number 1. An inversion layer can happen even here in Boston. All right? And it puts a cap where air can't flush upward. Usually, normal air or normal atmosphere, air near the ground gets warmed by the ground and rises like an eagle, taking air pollution away. Taking air pollution, that's normal. But when you get cold air coming off the Atlantic Ocean and sliding underneath our city, it can't rise. And the air pollution goes into that, can't rise. And it does not flush away like an eagle. And that's how it's made. Cold air underlies warm. Okay? Greenhouse gases include nitrogen and oxygen, water and chlorine, water and sulfur dioxide, CO2 and methane, and ozone and nitrous oxides. All right, polls are open. This lecture 1 week ago I gave to you. How well did I teach you? How well did you learn? All right, we're on. There's the countdown. Hey, get in here. I'm here, I'm here. Ticker time. All right, 2 more seconds. Good, good. And a lot of you said CO2 and methane, and that's the correct answer. All right? Yeah. So you did better on that one. Good job. The first nationwide U.S. legislation to curb air pollution was in. I'm going to change this. I'm going to change it in this way. The most significant legislation to curb air pollution, because there was air pollution legislation in all those decades. The most significant one to make the first really big change was it in the 50s, 60s, 70s, 80s, or 90s. All right, the first really significant. And you choose. Polls are open. 10, 9, here we go. All right. 5 more seconds. 3, 2, I wonder how you'll do. And you said, wow, I felt good about that in the 70s, all right? Along with the Clean Water Act. There were subsequent amendments in the 80s and 90s. We have more to do. Bonus question. Oh. Well, let's find out. Let's just go ahead and guess. This is a non-binding survey to see where you are. All right? Kind of fun. You're all curious anyway. Fire away, fire away. Woo, woo, you already know. You got 10 seconds? I got more people responding to this question than all the others. I didn't know I had 122 people here today. Okay, what do you think it's going to be? Whoa! And there's no right answer here. All right, so 88% are going on the field trip. Boy, are we going to rock! Woo-hoo! Okay, our next one on the class, Paul Hall did for me on ice ages. He said he had trouble with some of the videos. Okay, so now I help you with that lecture. If the front of a glacier is observed to be receding, which they all are today, it is most correct to infer that the glacier is moving down as fast as it melts, moving more slowly down as fast as it melts, moving faster than it melts, being pulled back uphill. They recede. How do glaciers recede? Does the ice pull back uphill? All right? And so now we'll go over here. We can now, the polls are open, just now. And you have a countdown, moving down as fast as it melts, moving down more slowly than it melts, moving faster than it melts. That sounds like number 1. Okay, polls are closed. A whole lot of you said moving more slowly, and that's correct. All right, so here's summary. Ice is always moving downhill. Sometimes it gets stuck, and then it'll surge, but in average, it's always moving downhill. We can test global warming by whether or not it's melting faster, and it's in. If it's not melting faster than it's moving, the glass ice will advance. That would be a cold edge. Okay? And if it's melting back faster, which is what they're doing today, then it's moving down, then you're in a time of global warming. If it's constant, then we're not having global warming or cooling. So we can go around the world and have glaciers as a thermometer, just like that thermometer that your mama put in your mouth or your dad to see if you're a little bit sick. Okay, glaciers aren't that for us. Okay? All right. And guess what? They're melting back all over the world. Only a few narrow exceptions. Wind-deposited glacial flour from great dust storms at the edge of glaciers. What do we call that? What was that word? And sometimes you guys are wondering, what does he want me to know? Well, there's one right there. So what's the name for that dust? Till, lust, dundrift, esker, came, all these glacial terms. What do you recall? Do you recall? And the countdown is down, far away, almost done, and you said, ooh, lust. You lost on that one, so let's review. This is why I do this. Till is a sedimentary rock deposited directly by ice. Right? Boston is covered with glacial till. All right? with young glacial tilts all over the place, boulders everywhere. All right? And there was an earlier ice age that a long time ago, 600 million years ago, another ice age deposited till all over the Boston area. It's now a rock called conglomerate, the putting stone conglomerate, the Roxbury conglomerate. Okay? That's till, directly by ice. There's also water-deposited sedimentation from melting glaciers. All right? And there's wind blown. There's wind blown because as the ice melts back, it leaves a landscape barren of trees and grass. And the dust storms start. And that causes loess. Okay? Idaho potatoes grown on loess. All over Illinois and Iowa, loess. Question. There was a saw it. Who had a question? Okay. Charmin. Okay. All right. Good. So we're learning. A pyramidal-shaped mountain peak sculptured by glaciers is called a what? All right, a ret, a col, a circle, a horn, a roche. Ooh, poles are open. Make a good stab. Here you go. 6 more seconds. What do you think? Pyramid shape. Pyramid. And you said, a lot of you, a horn. Very great. That's the correct answer. But let's review. An arete, which is the other term I do want you to know, is a sharp ridge carved by 2 glaciers. Okay? Like the edges of a knife, arete, ridge. All right? 3 glaciers, you take at ridge and you shape it on a third side, you're left with a horn. Landforms characteristic of valley glaciers include horns, aretes, and cirques, hanging valleys in moraines and great scenery, U-shaped valleys, lateral moraines and aretes, glacial erratic cirques and fjords, all of the above. What would Dr. A be doing here? Fire away, 10 more seconds. Good. Multiple choice, a little bit harder. And these are terms that I want you to know. All right, they could go into fill in the blank. And you said, 75% thought he's going to go with all the above. And guess what? I did. Good job. All of those. No other geologic process but ice makes U-shaped valleys, sharp ridges, horns, leaves glacial erratics, the big boulders left out in New Haven, Connecticut, and all over Boston. All right. Water-deposited glacial deposits occur in moraines and drumlins, eskers, kettles, and outwash plains, horns and cames, aretes and cirques. None of the above, sir. Well, what do you think? Polls are now open. Why is this important? Because the Earth has had great ice ages. We're coming out of one. The ability to understand that the Earth has had such great changes means we've got to be able to recognize those features that are created by ice age times and when they go away. Okay, there's the pole. You're still getting there. Look around. It used to be a lot colder here. 3 more seconds. Good. All right. And you said, eskers, kettles. Good job. That's the one. All right. In moraines are created just by ice. Horns are erosional. Aretes are erosional. Okay. So only one of those really fits. So you can see we've got a broken screen. We're only on one side. So if some of you find you can't see well, you can still pick up and move right now. Okay, got plenty of seats over here. All right? Now would be a good time to do that. But I hear they're getting it fixed. climate change. This is actually a 4-part lecture on climate and how it's changing. And on Thursday, I'm going to convince you never, ever to go and sunbathe unprotected. Because we're going to talk about the thinning of the ozone, a different ozone, in the high atmosphere. All right? This is number 3 out of 4. On the flip side, as we warm, we're losing our glaciers, and all over the world, the desert regions are growing. It's called desertification. All right? And deserts are moving into areas that we used to grow crops. We're losing land that used to be farms. Sand is moving in. So deserts are there. Part of it due to global warming. Part of it due to how we abuse the land. Overgrazing, sucking out all the groundwater. Salination. If we irrigate too much, irrigated water is full of dissolved salts. And every time you irrigate, you leave that salt behind. But it's not going to evaporate with the water. All right, good job. All right, urbanization and mining without putting the land back the way it was. So we are treating this place not too good, and we're going to see something new here. One of our agents of erosions we haven't really talked about because it hasn't shown, and that's wind. Running water, ice, gravity are all powerful. Wind is the weakest, but now it has a role, as you'll see. Wind, because there's not much vegetation there to hold it back. So, where are the dry regions? Where is this happening in the world? Well, there are 5 areas that are naturally dry. One of them is in the polar regions. We think of the poles, Antarctica, or the North Pole, with snow on the ground. It must precipitate a lot. It turns out it doesn't. You go to Antarctica, there's snow on the ground because it's years old, but it doesn't evaporate in that cold. And if you look up at the sky, Antarctica, the sky is always blue. No precipitation. Very dry in the polar regions. And likewise in the tropics, all right, tropics of Cancer and Capricorn, 25 degrees north, 25 degrees south. These are areas, all of these, polar and the tropics, of year-round atmospherically high pressure. And if you have high pressure, atmospheric pressure is high, storms can't come in. All right? So weather fronts can't come in. So it stays dry. It stays dry. All right? And that's what we get. We can categorize the dry regions as fully arid or not so arid. We call it semi-arid. Okay? There it is. Come with me. And here are the dry regions. At high pressure in the poles and high pressures in the tropics. And what happens is that the equator is closest to the sun. And so air rises at the equator and it's moist. It rises and cools and it rains over the equator. So the equatorial areas get a lot of rain because it's closer to the sun. The air rises. When you go up, does the temperature get warmer or colder? Colder. And cold air holds less water. Write it down. Cold air holds less water. So when it rises, it precipitates. And now that air no longer has that water, stripped of its water. Then that air goes to the north or to the south and comes down and it gets heated again. It's getting closer to the earth. It's already lost its water and now it's getting heated. It's making it even drier. So it's doubly dry. When you use a hair dryer, do you put it on cold or hot? Hot. Because hot air holds more water. Just the opposite. Write it down. Hot air holds more water. Therefore, it can dry everything out. So the polar regions and the tropics are doubly dry by this process. They lose water by rain over the equator, and so it's lost water there, and then it comes down and gets heated like a hair dryer, so it's blasting. It's blasting. All right, there we go. That's 1 and 2. 3, 4, and 5 are due to geography. It's because when wind carrying water moves over land and hits a mountainside, it rises. Is the air above mountains cold or hot? It gets colder when you go up the mountains, right? And so when the air goes over the mountains. 1, 2, every time it loses some of its water. Now they gain it back again. All right? And then spills out on the backside. So these are the name of rain shadow deserts, also deep interior deserts where just lots of mountains for it to move over. And so as the air goes up, it rains on this side, forming a rainforest on the ocean side, and it comes down over here, and it's doubly dried as well for the same kind of mechanism. It loses its water here, and then it comes down, and it gets re-warmed, getting closer to the surface. It's warmer, hot air. It's like your hair dryer. All right, so there it is. And the 5 is a coastal desert. It's just like this, except the ocean here is on the windward side, and now the ocean here is on the downwind side by cartoon. And so the wind goes all the way across, hits a mountain on this side. Over here on this coastline with the ocean, you still get a desert next to it. And that's true of much of South America. So we look around the world, we see the huge tropical deserts all the way across, tropical deserts in Australia, South America, South Africa. And then here are the geography deserts. Coastal in this region. I'm losing my pointer, so you have to bear with me. Rain shadow up in the west. So there they are. Amazing. And that's the deserts. And in the deserts, there's not much vegetation. And this is happening all over the world. All right? So you're thinking, well, I'm going to stay my whole life right here in Boston, so why do I care? No, you're not. You're going out into the world. All right? And these are some of the issues that the world is facing. For the last 10 years, we've been sending far, far too many, I would argue, women and men forces into the Middle East, where they're fighting battles and coming back with tough times. And part of that tough time was dealing with the climate in a desert region. Look at that. That's a dust storm coming at you. Phoenix, Arizona. Woo-woo. Look out. Amazing. Coming into the city. And historically we've had this. The Dust Bowl, 1930s, Oklahoma region. It was in a drought, and the topsoil was precious. You allowed it to blow away, it's gone. Okay?
Christina said, check this out.
Check this out.
Unreal.
Here are our troops.
Look at this. Look at this. It is unreal. And we're about to get crushed. We are about to get crushed. This is about to go goodbye. Look at the vertical extent. Something out of the Mummy. What are we going to do? Oh, it's about to go.
About to go. Can you actually look at that? If you're wearing contacts, you better get them out. Whoa! So, dust storms, they blast along, and the sand and silt and clay get carried along, blowing. So wind, now, agent of erosion, all right, our fourth one, our weakest, but now it's got to roll in the deserts, and there it goes. I mean, you got a brand new shiny car, and you're driving to Las Vegas, and you look out and you see this, what do you think you better do? You're going to lose your paint job unless you turn that car around. Do you remember this lecture from Earth Science 105? Look at that. And it's the sand and silt and clay, from coarser sand to very fine clay, get carried in different ways. The clay and silt get carried in suspension, so they're airborne. But what's going to blast your car is what's being carried by what we call saltation. That's dancing sand on the surface. It's dancing sand on the surface. The word saltation has nothing to do with salt. It's from the French word saltaire. It's dancing. So the sand grass, look, I'm dancing, I'm dancing, I'm dancing, I'm saltairing, okay? So the heavier particles, they're the ones that are going to blind you. Look at that sandstorm. I put a telephone pole here. Let's say you're going to go out to Lake Havasu, Arizona and buy a home. Oh, what a lovely place you'll be. And you look around, you notice that the telephone poles all have bottoms that are bleached. What did that? What did that? Saltation. Blasting sand. Hey George, Mary, I think you shouldn't buy that home there. They get sandstorms, okay? Maybe so. And as the sand moves away, it creates a very fragile surface that I want to share with you called desert pavement. It blows away all the sand and the land lowers. That's called deflation. So land is eroding. Deflation. And as it lowers, then you're left with only the cobbles that could not blow away. The pebbles and cobbles that couldn't blow away. And so there they are. It looks like it's a human-made surface, but it's created by wind. And it's a very fragile surface. If you drive on it, your car tracks will never go away. All right? So look here. Here is an area of, I took this picture from a helicopter. Here is an area of desert pavement. Here's a wash. Here's a wash. There's a wash where streams flow during flash floods. But there's a flat surface created by wind, ablation, blowing away the sand, leaving behind this fragile surface, and already there's a car track. All right? So that's how it goes. Deflation, deflation. And finally, desert pavement here on the far right. I need new batteries, and it's very fragile. So when you drive on it, walk on it, you're leaving tracks. And I don't know what kind of tracks you wish to leave in your life. I hope a great novel, sculptures of art, songs, all right? But just these raw prints, not so wonderful. So that's how desert pavement is formed, right there, by blowing wind. And look at those tracks. Now these tracks are interesting. These tracks come from World War II. I took these as well from a helicopter. These was the training ground of General Patton, all right, getting ready to invade North Africa, training in the Mojave Desert of California. Those aren't car tracks, they're too big. They're tank tracks, left by your grandparents perhaps. Amazing, they're still there. Look at that, all over the place. So that's kind of a bit of history. This, if you want to go out and make tracks, do it in the sand, all right? Get on a sand dune. Yeah, woo-hoo, yeah, it's good up there, but if you do get on one of those vehicles, don't get the three-wheelers, get the four-wheelers. The three-wheelers break necks, but they're fun, all right? The sand blast, it actually sandblasts rocks. It's called a benefact, sculptured by blowing sand. Running water still remains as the most powerful agent of erosion, and it gradually takes down mountains, reducing the land to a flat surface called a pediment. A few isolated rock mountains called Inselberg will be there. And beautiful lakes that come and go. And when the lake water evaporates, you're left with a mud flat called a playa or a salt flat. Here is a playa, just a mud flat. There was once a lake there. It'll come back. Next time it rains, there'll be a lake. And the frogs that are down in the ground waiting for the moisture to return are there. Right? They're all there. Life in that deep, dry mud, a playa. So running water, most powerful agent of erosion, making V-shaped valleys, floods out of the mountains. And we've already talked about these alluvial fans, so that's okay. But there's a pediment. Mountains were once here. Running water is still the most powerful agent of erosion, taking down mountainsides, leaving behind Inselbergs, or island mountains, Inselbergs. There they are, beautiful. Surrounded at times by a sea of sand. There's art out there. In just a few weeks, I'll be taking a whole bunch of DU students out into Death Valley in the Mojave Desert. And we'll go climbing around and hiking and camping out. But we'll look out for these things. That's a cloud. But something's getting bigger. It's getting darker on its bottom. Oh gosh, a thunder cloud. Holy hell. So a dry wash. Next day will look something like that. Woo-hoo. This is a small flash flood. You can run out and play in that one, but sometimes they're not always so small. One time, just like I'm doing with our students here, I took a bunch of students from Minnesota out into the Mojave, and we were having a wet year, and the waterfalls that usually are dry were flowing. And I could hardly keep these people from taking their clothes off. Well, he's got most of his clothes, some of his clothes on. Right? Oh, what's that? Hands in Borrego. Just to the east of San Diego, flash flood. And we've seen some pictures of flash floods. So there they are. Running water, most powerful agent of erosion, even in deserts. Go. And the DU students that I'm taking will go here. And these are the Kelso Dunes. They're beautiful. Sand dunes. Wind erodes, leaving behind a deflated land and a desert pavement, but where does that sand go but to a sand dune? Sand dunes are beautiful. They move very slowly by blowing wind, and they do a remarkable thing. They sing. They're called singing dunes or barking dunes. When you walk up here, the sand trombones. Boom, boom. That's because the sand is all frosted round. And as you cascade the sand down, it traps air underneath. And just like a saxophone, it erupts with volume, all right, depending on how dry the sand is. And there's my good old dog Nugget barking at the sand that was singing back to it. It's like, whoa, 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 whoa. Hey, old dog Nugget's in dog heaven now, but it was a good companion. Used to come to my classes every day, sit at my desk. Yeah, I love the dog. We love our animals. So as the sand dunes migrate, and if you don't look out, they'll come in your backyard. They move, in this case to the right. And where the sand dune was in a solid line now is dashed. It erodes on the upwind side and gets deposited on the downwind side. That downwind side is called the lee slope. And that forms inclined beds. We call cross beds. So when you look at sedimentary rocks that have inclined beds, don't you see you're looking at the insides of what was once a sand dune, even after the sand dune is gone? Come with me. See there? So here's how sand dunes form. And they move. And the steep lee slope is always on the downwind side. So I will ask you to know that. You know, how do you tell which way a sand dune is moving? Look for the steep side. And that's the downwind. The shapes, I will not require you to know the different kinds of sand dunes, but I'm going to tell you about them because they're beautiful. Barkans have these horn shapes, but notice the steep side is up on the right, upper right. So it's moving to the upper right. All of these are moving to the upper right. Transverse goes oblique. Here's smaller transverse, larger transverse. But the steep side is the downwind. So the wind there is all moving to the upper right. Barkans and transverse, longitudinal dunes, parabolic dunes, star dunes, all different shapes, which I do not require you to know, but just to appreciate that the sand dunes take on different forms depending on the availability of how much sand there is. There, look at that. You can see some sand moving, coming away from you or toward you. Toward, yeah, way to go. Moving toward you, the steep flat sand is moving toward you. Would you put a home right here? You're going to have that sand in your bedroom. Hey, honey, somebody's here. You're kind of sandy tonight. Yeah, pretty good, huh? So, sand. Which way does the sand go? All right. This is a famous little barking dune all by itself down near the Salton Sea in Southern California. In 1958, they put in this road and had to go around it. And now let's go 15 years later. It's on a pediment surface created by running water during flash floods. That little old sand dune out there all by itself, still moving, all right? Wow. Now it's over here. Give me, you go back. Wait. Yeah? Here's a road without telephone poles. And then there's the same road. It's got that. Look how much it's moved, okay? So 15 years later, it's moving slowly. Out there all by itself. And this is up in satellite view. Tule Barkin, it's got a name, Tule Barkin, close-up view of it. Inside, it's got cross beds, lovely. Here's another one, a different place. I could not find where this is from, but I know the author, so I'll get it. But here's two Barkin dunes, one over here in the upper part. Come on, won't work quite. And then this is the arm of a second one, and it's cut off the road. Did it a long time ago. Now they needed a telephone line, so they put the telephone pole on top of the dune, and on they go. So lovely shapes, art, and cross beds, the inside structure of sand dunes. Their tops are always steep. The bottoms are always shallow, so they're coming down like that. They tell you the direction. The wind is blowing in the downwind side. The wind is blowing in the downslope side of the cross bed. So when you look, let's go to Zion National Park. Here we are. and look at these Jurassic rocks, 180 million years old, and look at that. They're all cross-bedded. The sand dunes are gone, but the internal structures of cross-beds remain. Wow, look at that. Millions of years, layers upon time, layers of time. As we go up, you're getting into younger and younger rocks. And you look at that whole hillside. And you're looking at eons of time when there were sand dunes covering this part of the world. And was the sand blowing in the same direction? Are they all right here? Is the sand, are they, yeah, that one's more clear, isn't it? So that, you know, you're looking back, you're reconstructing the climate of planet Earth 200 million years ago. And you're recognizing, wow, this was all desert, all covered with sand dunes. And for years, upon millions of years, it's continued, and the wind howling in the same direction. That's amazing, to reconstruct what the Earth was like. Go to Arches National Monument. Arches are beautiful. That's the way they're weathering. But the inside is all crossbed. It's all there. Some great dunes. But they are growing now. As we lose our glaciers, we're gaining deserts. And here we are in Egypt. And bark and sand dunes are moving out across fields. We can no longer grow crops to feed the hungry. And on Mars, Mars has wind. Mars' atmosphere is very thin, mostly CO2. But it's there, and it howls. The wind howls. We have little robots that are traveling on Mars right now, right? And they get blasted by the sandstorm. But look at the bark and dunes moving out across, moving out across. Are these bark and dunes moving to the lower right or the upper left? Lower right. You got it, girl, boy. Way to go. And there's opportunity. Making tracks. Woo-hoo. Looking for a crater. It'll take about a year. It's traveling across the sand. All right? The desertification is a global issue. As we're losing our glaciers, the planet is drying, and the deserts are growing in all ways. But now I just want to share some, you sit back and relax, some beauty of our deserts. I did not know much about deserts until I moved to California some 35 years ago. And I looked at it when I first looked, drove across the Mojave from Needles, California, out of a U-Haul truck, and I looked out there, and it was hostile looking, and it was hot, and cactuses, and who'd want that? And yet I started taking geology field trips out there right away, and going out and looking, and seeing the natural beauty. This is in Australia. Look at that. Why do you think Kansas wrote that song? They found, looking at the hostility, apparent hostile nature of deserts, you see, oh my, wait, this is what nature is. It's dust in the wind, right? What a grand song. I misspelled Australia. And you got the words? All right. So, you know, it's out there. It's great. We've been talking about sand dunes, but on the sand dunes, there's actually little ripple marks as well. They're a lot like sand dunes. And they're beautiful with a dime for scale. Here's just some grass growing and the wind changing its direction at time. Even the grass is acting like a paintbrush making art. You understand, look out, observe these things. And the desert's full of life. It's not hostile, unless you're there in July. How beautiful. Saccharol, great cactuses, creosote trees. Creosote trees have no leaves. So they're adapted to the desert. Their chlorophyll is in their wood tissue. And who's there? What do you see? Yeah, what kind of rabbit? Jack rabbit. Hey, Jack, got along. He's there. And mule deer, they're there too, in great abundance. Oh, I got to tell you this story. A ring-tailed lizard. Now, ring-tailed lizards are kind of fun. And what I did with this lizard is I caught it. But I did it in a very nice way. I had some thread, and I made a lasso on one end, like with a rope. And because lizards don't like to look in your eye. They don't want to look in your eyes. So what you do is you don't look them in the eye. And so I had my lasso out, And I got over kind of to it, and he's sitting there looking at me, and I'm not looking at it, so he doesn't know what to do. Lift a little lasso around its neck just for a moment, and then you pick him up. And then you can do this. You rub a lizard's belly, and they will go to sleep. I mean, what if somebody rubbed your belly? What would you do? It was okay. I woke him back up, and he went darting off. Oh, look out. What is that? Yeah, rattlesnake. I've been struck at 5 times in my life and not yet bitten. But, woo-hoo! They're, oh, what's that? Tarantula, yeah. We get balloons of these. I remember one time at night, we were driving down real slow down the desert road. All of a sudden we heard poppy, pop, pop, poppy, pop, 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 pop. And we looked out, and we're driving on hundreds. Yeah, imagine they're going into your tent. The desert tortoise is being threatened today because the raven has arrived. The raven came out of Colorado following our garbage dumps. And the raven knows how to pick these things up, fly them up into the sky, and drop them. Yeah, so the desert tortoise is really being threatened. And we've also learned when they get in the road, I would get out and pick them up and just move them over thinking I was doing a good thing. But then I noticed it peed. And that water in it is very, very sacred, of course. And I just made it pee when it needed to keep that water. So now my message is, let the tortoise go around. All right? So it's all there. Let's see what's now. Oh, look at the big coral cactus. They're lovely. They actually have water inside. They've got skin that's full of chlorophyll. So they're doing photosynthesis. And they're holding their moisture inside. And that's one of these Minnesota students making love to a cacti. He's smiling. And the burrows that are out there actually came from Europe, brought in by gold prospectors in the 1800s because they can travel forever. They need very little water. Oh, what a plant, the jumping cholla. Look at those needles. You get those in you, and you've got quite a bad time. But look. Baby bird nest hiding away amongst the needles, a natural place for it. The flowers out there in the springtime, we're going to be there. On a good wet winter, they come out with many different colors. There is the ocatilia in full bloom. It says, I love you. Footprints in the sand. Also taken by our troops. Look at that. Saudi Arabia. What is coming on? Oh, man. Bid you all farewell. Hope you enjoyed your introduction to the world of business.